Okay, this is Mario once again with MIA Microflight, and what I'm doing here is I am cutting a 5-inch hole, or I should say, I am enlarging this 4-inch diameter, inside diameter, a solid tubeless wheel. This is made out of PU polyurethane foam, so it's a high density foam that is used for making these tubeless wheels. So I decided to do this so that I can fit it over my these brushless motors. And the way that I'm doing this second one is a little bit different than my first one, and I think this is going to be better. I actually 3D printed this fixture here, which is has the same inside diameter as the original wheel, and then I have this brass rod here that's connected to my my spindle here, my drill press, and I center that so that I can lock it on the table here. This is my drill press, and it's the wheel is locked with these two C clamps, so that's not going anywhere. I already did the other side, so I inverted it and I recalibrated this so that it's concentric with the cut, and so that both cuts on both sides will be equal or concentric to each other. This saw that I have here can only go about 1 inch in depth, and that's the reason for doing this in halves, one half, and then flip it to the other half. It's a little bit tedious, to calibrate this and adjust, but with a fixture such as this 3D printed part that I am showing here, it's a lot easier. And so I already did one wheel, and it worked just fine. After I cut this, I have to come back and I have to create another 1/2 inch of recess here for the lip, for this lip, so that it sits inside this, and that's got to be a little bit tight so that it grabs onto the wheel. Besides, having the little grip from the 5-inch cut, this actually is going to cut this. It's not going to be super tight, but it's not going to be loose either. It's just a precise fit there. What is actually doing the gripping more than anything is the recess that I'm going to create here. Once I'm done cutting this for the 5-inch diameter opening, I have to offset this wheel to the side and pop this guy in there, and so that I can come back and kind of shave a recess 1/2 inch deep on both sides. So I have to do one side, flip it, and do the other side. I'm using this drum, the sanding drum. I mean, you can certainly use a smaller one, but this is what I have with a semi-decent sanding surface here. So I'll come back and do that. It is nasty in terms of this, releases this really fine dust here. So you have to wear a mask, wear eye goggles, to protect your body, your lungs, your breathing. So. And this stuff is, gets all over the place, so you have to use a vacuum. I have a vacuum next to me that I'm vacuuming this once I get it done. I should have a vacuum installed here with some kind of a holder, so as I'm cutting this, the vacuum is sucking all that stuff. But because I'm only doing 2 wheels, I decided just to just go ahead and do it this way here. Wanted to do this video explaining how I'm doing this. I decided to do this in lieu of the other wheels that I cut, for a 5-inch diameter hub, and the ones that use the tube, because those were a little more cumbersome to assemble, and I didn't want to really cut, a hole here for the air filling inlet. So I don't want to modify these things beyond what they already modified. I already drilled some holes in a previous attempt of modifying this and adapting this to a wheel, but I didn't. As you can see, I didn't want to go with bolts from the inside, because that has a risk of damaging the windings. So I don't want to touch that, and I don't want to touch that any further. So I rather just modify these PU wheels the way that I'm doing it here. You do need a 5-inch diameter saw like this, circular saw. You can also do this with a if you buy this in a set. I think Harbor Freight sells these cutters in a set. I think that's where I got my set. So it's been a long time, and it came with various sizes. This is a 4-inch one. You can also attach this attach it with this hardware here that it's already attached to the other one. So I was saying you can attach, you know, that the drill bit with the nut in this shaft here. You can attach it to this 4-inch one, invert it, and use that as your centering jig, you know, until you're able to clamp this. The table has to be locked. So we're going to lock this in place, and I'm about to, since this is already centered, the way I just showed here with my fixture. If you don't have a fixture, you could use this other thing that I said, this other circular cutter, 4-inch one, and because this is a 4-inch diameter original opening here, you can center that there, and then get this have this retain attached, you know, with these C clamps, so that the wheel doesn't move. And then you pop this larger one, which is what I'm going to do. I'm going to remove this and then come back and cut the wheel. Okay, on the drill press, sorry I'm wearing a mask already because I'm going to be cutting here. On the drill press, you're going to have to set this to a lower speed. I have it set to 1100 RPM on this belt pulley system here, so that's on the low end there. And that is so that when you do this, you do it nice and slow. So hopefully this is not going to move on me. This is locked, and here we go. This saw has it's not a really good saw. It's got a little imperfection there, so it wobbles a little bit. But you know, for this job, it's okay. And so I'm just taking my time and going really slow. And once it grabs a good you know, 1/4 inch, then I can go lower here. So I'm gonna have to either lower this or raise it. Oh, I can't raise the table because it's going to disturb my centering. So I'm gonna have to lower this tool a little bit so it cuts a little deeper. Okay, I already cut. I just wanted to show how deep I went here. I already cut it, and this came loose here. You gotta make sure that that's tight on the machine, but I already cut it. As you can see, that's as far as I'm gonna go there. So now that I have both cuts on the top and the bottom, now it's a matter of taking out the wheel, and yeah, it doesn't need to be center anymore, because the next two cuts are going to be for the to create a step there, so that this lip is able to sink in there. So I'm going to countersink this, come in about 1/8 of an inch here, so it's nice and tight on this outer rim, and it'll sink about 1/2 inch, because that's how far it needs to go, because this wheel is a good 3 inches in height, and this is only about 2 inches. So 1/2 inch on each side, you know, removes 1 inch total. So that's what I'm gonna do now next. Okay, I cleaned up all that debris and dust, this foam dust. As you can see, the back, this is my fixture, 3D printed fixture that I did, and this hole right here is just to allow me to center it with that rod that I had here on my drill on the spindle here. So I'm going to remove this now that I have established my cuts, my 5-inch diameter cuts on both sides. Once I remove this, you'll see the other cut, because I already cut this side right here. This is very snug fit there. So I'm gonna have to pause the video, remove this, and then come back to it. Okay, I removed the fixture, the 3D printed fixture, and what I have here is a cut that's going about 1 inch deep here, because this is 3 inches. There's probably another inch here of material that needs to be cut. And so the way I'm cutting that is I'm taking the wheel and using this. This is just a piece of bandsaw. You know, sometimes I keep these parts right here that I can use them as just manual saws, and this works excellent, for doing what I'm going to do here next. I'm going to shove that in there and just go around this and come back and finish the cut so that this inner ring falls off, and I'll have my 5-inch opening here complete, that I can insert my hub motor. So I'm going to pause the video, I'll do that, and I'll come back here. Okay, the other thing you can do, which might be a little bit better, is just to lock this cutter here on a vise. I have this on a vise, locked it on the nut, and I'm just rotating this around and just going slowly back and forth until I can reach the center here on both sides. I flipped it over, and basically when you're done, you end up with this piece that comes right out, and you can see how deep this thing is right here. And it's not going to be exactly perfect, because when you do this with jigs like that, there's always a chance that you're not going to get the same exact center on the cut. So it's going to be a little bit off, but it's not really that critical once this is mounted on the motor. But as you can see, I just finished this guy right here, and there's the wheel when it's cut. It just needs a little bit of cleanup, and or you can just leave it like that. Just clean up these extra material here, and just clean it up lightly so that it fits nice and snug on this brushless motor. So I'm going to do that, but before I do that, like I said, I have to mount this back on this drill press, set up my drum, my sanding drum, so that I can come back and recess this, kind of sand that section, to about a 1/2 inch deep. So I'm going to do that. I'll come back to this video. Okay, so in order to do my next step, I have attached this sacrificial board right here on my drill press, and then because this already had the holes, some holes already there, I attached this as my fixture so that I can pop my wheel on it, and then I'm going to rotate it. It's offset so that this comes and cuts a recess on the edge of the tire, for this lip to go in, as well as the cap here. Okay, so using this hoverboard motor case as my fixture, that's attached to this board here, and this board can be moved in and out the way I have it set up here, so that I can adjust the distance from the edge here, offset that, so that I can come back and just go around, just move the tire around as this sanding block is doing the job there of creating this recess here, this pocket or a step. This right now is set to maybe 3/32 of an inch, so I may need to kind of just tap my table so it goes in a little bit further, and that's how I've been doing it, just to control the depth of cut around the perimeter here. So I'll do that. This is about 1/2 inch, a little bit shorter, because I want this to be, when I assemble this, when I pop these inside and it sits on top of these, on top of this edge, I want it to be nice and snug. So I rather have this height from this edge to the bottom edge, which will be recessed as well. I want that to be a little bit higher than the height of the height in between the two lips of this case here, so that when I press it, when I screw it on, it compresses the foam here. This foam is very, very dense, so it's not like a it's not like a foam mat that you exercise on top of. Those mats are very soft. This is really dense foam. So it's very hard to press it with your fingers. So this has to be done, rather, maybe I'll leave on 1/32 of an inch in height, or somewhere around there. I'm kind of eyeballing these things, and if I'm not exact, it doesn't need to be that exact. But basically, that's what I'm about to do in this video here. I'm going to stop the video because this is really messy. I'm going to have to set up my vacuum cleaner here, so it'll vacuum this as it's cutting here. And I'm wearing a mask. That's why I'm sounding a little nasal. to do this, and this stuff is nasty, nasty stuff, because you know this is what comes out of that, and it just clings on a lot of things, on the tools, on the tables. So after this is done, I have to come back and clean my table and my tools here. It's just something that part of the process. Just be aware. Okay, so I just washed my hands here because it was a little dusty. So basically, that's what needs to be done. So I'm just going to continue cleaning this a little bit more. Okay, that should do it. Make sure that there are no metal shavings or anything that may have gotten stuck to these magnets. You don't want anything rubbing once we reassemble this motor with the windings, with a winding armature. And so here's the tire all cut and ready to be assembled right on this hub here. And we can see here that the distance, this inner distance right here, has to match that width right there, the inside of that. And this lip right here, which also becomes this lip here once this cap is on, that provides the the retention on this. It locks up via this step right here. So that's going to sit right there, and then the cap, the cover, is going to sit on the other side. And as I was saying in my while I was cutting this, if this distance is a little bit, just a little bit wider than this right here, we have compression here. We can compress this in place, and it'll lock it even better. But I think this will be fine once we assemble this. I know that this fits already in snug on this thing because I was using this as my fixture. So I'm going to assemble that and come back to this video. Okay, so we can see here, you can see the distance here, the depth. I had to put this on the floor and kind of press this with my weight on top of this. I stepped on this, and that went all the way in. Otherwise, it gets a little tight to press this by hand. And so that's the way I press this right on the wheel. And I don't think that's going to shift or come loose anytime soon there. And then this other one right here, as we can see, there's a step right here, and that step is has a little bit of a rise, a little height above this this edge here by about maybe I would say about 3/32 of an inch. So I'm good there, because once I put this plate there, and once I assemble it with the windings, that should compress really nice with the screws, and that'll lock this this in place. And we have the same height right here on the edge. So this is sitting inside. As you can see, the wheel is sitting inside, kind of clean. And the same thing would happen on this side, on this other side. So this hub, in other words, is centered with the tire. So I'm going to do that next, and I'll come back to this video. Okay, so I was able to press this same method. I had to step a little bit on the sides here just to get them in kind of even. You want to do that evenly. You don't want to press too much on one side. And now I'm installing the screws in opposite direction, kind of loosey-goosey for until we get them all in place. And the way these screws need to be done is you can do them in criss-cross form. And then you tighten them the same way. One across, the other one across, the other one across. And that way you establish an even tightness on all the screws, and everything's nice and cozy, nice and even. Okay, I had to tighten these a few times around because of the extra foam material was higher on the flange, on the lip where this sits. So I had to compress this, so that it mates with the hub the other side of the hub. So I had to go around a few times, and I just put a little more pressure on the screws here. And you can feel it once you tighten one side, the other side's kind of remain a little bit loose. It's because it's compressing the foam, and then just got to go around a few times to make sure that everything is nice and even, nice and tight. And at the last thing you want to do is you want to test the tire. You know, I want to give it a spin. Let's see if I can spin it here. It's pretty good, pretty even because I took my time in doing the fixture, making sure that that's center. You're not going to get it exactly perfect, but it's good enough for doing this, with the tools that I just showed. There are probably other ways to do this. I think with a lathe, with a big lathe. Unfortunately, I don't have a big lathe because I don't work on big stuff. I do have lathes, but they're for heavy use. I don't have a lathe that will house this particular size 10-inch wheel, with some room, to come back and do the cuts there. Otherwise, this would work a lot better with the lathe and just a kind of a cylinder that chucking a circular saw on the chuck, and then coming back and just pushing that through as the lathe is spinning. Basically a lathe is a horizontal drill press in a sense, but you can do this with the drill press provided you make everything concentric with the with your jig or your setup. So that's my wheel right there, and it's a lot. It's a little more work because you have to prep, and you have to do the jigs, and you have to do the cuts, and we're talking about a cut at the top, a cut at the bottom, and then coming back and doing this recess, with the sanding drum, and doing the same thing at the back. And I have to do that twice, for both tires that are going to go on the rear. These are going to be my drive tires for my go-kart. And as I was mentioning in one of my videos, when I was testing the other ones with the tube tires, the ones that popped out, I really like the distance that this is covering, and it seems to have be a little more efficient in terms of power, because I ran around the block with it, not around the block, but I went up and down one of my streets here, and as I was coming into my cul-de-sac, the wheel popped out. So tubeless, the way I showed, unfortunately, it would work with those flanges that I showed, those blue flanges that I created from those cups, plastic cups, polypropylene cups. That would work also, but it's a lot more difficult inserting the tube, because that tube is also for a 4-inch hub. And so you have to stretch the inside diameter of that tube, which is it's really tricky, and it's a little bit difficult to stretch that over this 5-inch hub. You're stretching the rubber there, so it's not that easy. This, however, it's once you're done with these cuts, I mean, look at that. It's a gorgeous looking wheel, and so I am pretty much going to be doing my wheels this way. In fact, I'm probably going to set up a different jig setup so that I can do a few sets of these wheels, just to have them for other projects, because I really like the way this is coming out. The ultimate test, however, is in the model, not the model, but in the actual go-kart, and see how this is. I have no doubt that this is going to hold up. The only thing that I think I'm not going to have here is the pneumatic suspension, because these wheels are not really hard as the original tire that comes with these hoverboard motors. Because this is a little more, it has a little more give, because it's a polyurethane foam, but it's high density foam. The other ones are solid rubber tires. So there's a difference between solid rubber and polyurethane high density foam. This has a little more cushion to it, and I think it'll be just fine. 10-inch wheels, same wheels I'm going to be using at the front of the go-kart, just in the normal way, because they do come with some nice ball bearings. These particular ones I got at Amazon, with with a higher quality ball bearing, so that I don't have to buy the ball bearings and switch them, for the crappy ones that typically these cheap wheels come with. I got 4 of these wheels, 2 more. Like I said, those other 2 are going to be in the front of the car. I have some yellow hub wheels on the go-kart right now, so I'm going to swap those for the other 2 so they match, the same size, everything. And a happy camper here. This is already done. And you know we're talking about in terms of cost, what am I saving here for the effort that I put here? uh, I'm not really looking at it that way because I have spent quite a bit of time just trying to think of ways how to do this and do it properly and do it in a way that can be repeatable and testable, and it's proven to be good. There are other videos of people doing, putting in big tires on these hub motors, but I bet anything that if you put a tube tire, even if you go and get the 5-inch rim tire, the ones that would fit the 5-inch rim, because this has a flange of, I think this is about a 1/4 inch of a lip there. I don't think that's going to be enough for even a regular 5-inch rim tire, tube tire, to retain itself. I bet you that's going to pop at any time. If you happen to hit the tire in a particular way, there's the likelihood of that popping, just like it did on mine, is there. With this right here, the wheel is not going to pop, and not in the way that I just showed in this video. The way I assembled this, nice and snug, and everything is just a nice snug fit there. So I think this is the way to go with these motors here, and just using these wheels for sake of less complexity in the assembly. The other ones would work, but then you have to, like, you have to drill. You have to put the flanges. You have to put a flange that's going to hold the tire. Like, once again, this 1/4 inch flange that this has, I don't think that's enough. Even with the 5-inch rims, the unmodified ones. The ones with the tube, you have to drill a hole, on this side right here, to keep the inlet, to allow for the inlet, the tube inlet to stick out, and so you can fill the tire. So I don't want to modify that. I don't want to ruin these any more than what I already did. If you want to look at it that way, I drilled these holes because I was going to mount this to a hub of a wheel, but it's just not a good way to attaching this to a hub, and then have the hub sticking out. There's an offset. The wheel would have been offset to the side here, and now you're putting a lot of force on these 3 bolts here. So it's not a good way to do it. This is a much better setup here, much better compromise. And so I think as far as these videos that I've been doing, problem or solution, fitting these 10-inch wheels. These are 10-inch, by the way. It doesn't say 10-inch, but it's a 10-inch wheel. This 410/350-4. This this is the solution, I think, to mounting this on these hoverboard motors. I know it'll be more I think more secure than just having just the tire sitting on this very short rim here. Mario once again with my microflight. This project is done. Next video, I'm going to be putting this on my go-kart and riding it again later tonight, maybe. All right, stay tuned for more.